Here we have 0.750 bar of carbon monoxide reacting with 1 bar of hydrogen gas to produce methanol or CH3OH. The question asks us to find the equilibrium constant, or Kp. The first step here, once again, would be to rewrite the equation and to see if it's balanced. The equation here seems to be already balanced, so we can only rewrite the equation. So we have carbon monoxide reacting with hydrogen, and then we have methanol on the product side. Now that we're done with the rewriting, we can start with our ice table. Since we're dealing with pressure this time, we will have Pi, Pc, and Pe, which would mean initial partial pressure, change in partial pressure, and equilibrium partial pressure. So let us look into the initial conditions given the question. So for carbon monoxide, we have 0.750 bar initially. For hydrogen, we have 1 bar. For methanol, we have no information, so we're going to guess or assume that there was none to begin with, or 0. For change, we can set our variable to x. So for carbon monoxide, we will end up with negative x because the coefficient is 1. For hydrogen gas, we're going to end up with negative 2x. For methanol, we end up with positive x. Now that we have the changes, we know that our equilibrium partial pressures are going to be equal to that of the initial partial pressures and the change combined. So for equilibrium, we're going to end up with 0.750 minus x. For carbon monoxide, for hydrogen, we're going to have 1 minus 2x. And for methanol, we are just going to have x. Now, in our question, we are already given the partial pressure of carbon monoxide as 0.295 bar, and we have it as 0.750 minus x in our equation, or our variable. So what we do is that we go to our next step where we write, according to our question, 0.750 minus x seems to be equal to 0.295. That would mean that x is equal to 0.455 bar. Now that we know the value of x, we can plug that into our equilibrium variables. So since we already have x, which is our partial pressure for methanol, we can plug that in and we can write it down as our partial pressure of CH3OH is equal to x, which is equal to 0.455 bar. Similarly, by plugging it into hydrogen's variable, we will get partial pressure of hydrogen is equal to 1 minus 2x, which is equal to 1 minus 2 times 0.455, which is equal to 0.09 bar. Now, for partial pressure of carbon monoxide, we don't really have to do 0.750 minus x and plug everything in, because we already have it in our question, so we can just straight up write 0.295 bar. Now that we have all our equilibrium partial pressures, we can plug them into our equation for the partial pressure constant, the equilibrium constant, which is Kp. So for Kp, we know the equation is going to be the same as that of Kc, except we're going to be dealing with partial pressure. So it's going to be the partial pressure of products raised to their coefficients divided by the partial pressure of reactants raised to their coefficients. So for products, we know we just have one product, which is methanol. So we're going to have PCH3OH. And then for reactants, we have carbon monoxide, so PCO times, we have hydrogen, PH2, but then again the coefficient for hydrogen in our reaction is 2, so it's going to be raised to 2. Now we plug in our values, so we have 0.455 bar over 0.295 times 0.09 whole squared, and then once again for the units we have bar times bar squared. The bars get cancelled out. We end up with 190 and bar to the power of -2 for our value of the equilibrium constant. And that is the answer. Let us now move on to a more complex example.